our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start your physics class, that is being of class 11, and that is of part 1, which we had started, where we had in the this is your 9th class. In the last classes we had done your unit 1, we had completed that, which is about the physical world, physics and their physical world. Okay, and this is unit 2, which we had started, that is unit and measurement. And lastly we had done many of the last classes only based upon numerical questions related to physics, which has been important and that has been asked as well. So we further continue in this unit 2, which is we have to first start with discussing about the estimations of very small distances. So let's go for the same. Estimation of very small distance. That is size of molecule, size of a molecule. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Estimation of very small distances like size of a molecule that we talk about here. It's totally based upon like that, the measure of a very small size like that of molecule, which is of 10 to the power minus 8 meter to 10 to the power, that is for a small molecule that we talk about it, 10 to the power 8 meter to 10 to the power minus 10 meter, where we have to adopt a special method. We cannot use a screw gauge or similar instruments. Even a microscope that has a certain limitations. An optical microscope uses visible light to look at the system under investigation, as light has a wave-like feature, that the resolution to which an optical microscope that can be used in the wavelength of light, where a detailed explanation that can will discussed in class 12. And for visible light, the range of wavelength is from let's write it down this, so that has been the important one, of course. For visible light, the range of wavelength is from about 4,000 to 7,000, which is 1 angstrom. 1 angstrom is being represented as this, equals to 10 to the power minus 10 meter. Okay, hence an optical microscope that can resolve particles with a size smaller than this. So instead of visible light, we can with a size smaller than this, so instead of visible light we can use an electron beam. And electron with the use that, as I told you about the electron beam that can be focused by properly designed electric and magnetic field. The resolution of such an electron microscope is limited finally by the fact that electron that can also behave as wave, and you will learn more about in this in class 12 as well. The wavelength of an electron that can as small as a fraction of an angstrom, and such electron microscopes with a resolution of 0.6 Armstrong, and that has built here, they can almost resolve atoms and molecules in a material. In a recent times, tunneling microscopy has been developed, in which again the limits of resolution is better than an Armstrong, and it is possible to estimate the size of molecule as well. with the same a simple method for estimating the molecular size of that is your oleic acid is just to be given. And oleic acid is a soapy liquid with large molecular size of the order of 10 to the power 9 meter, where the idea is to first form monomolecular layer of oleic acid on water surfaces. We dissolve 1 centimeter cube of oleic acid in alcohol to make a solution of 20 centimeter cube, and then we take 1 centimeter cube according to that of this solution, and then dilute it to the 20 centimeter cube by using an alcohol, so that the concentration of the solution that equals to that is 1 upon 20 into 20 centimeter cube of the oleic acid per centimeter cube. With this that the solution that of solution, the next we lightly sprinkle some that is your lycopodium powder on the surfaces of water in the large trough, and we put 1 drop of this solution in the water. The oleic acid drops spreads into the thin and largely and roughly circular film of a molecular thickness on water surfaces. Then we quickly measure the diameter of the thin film to get the area A, and suppose we have dropped n drops in the water, and initially we determine the approximate volume of each drop, that we have your V centimeter cube as well. So volume of n drop, we'll find it out here. Volume of n drops of solution n V centimeter cube. Okay. Another is amount of oleic acid in this solution equals to NV 1 upon 20 into 20 centimeter cube, where the solutions of oleic acid spreads very fast on the surface of water and forms a very layer of thickness T, and if this spreads to form the film of area A centimeter square, then the thickness of the film we get as T equals to volume of the film upon area of the film. Which is equals to NV upon 20 into 20 ampere centimeter. If we measure that the film has mono molecule thickness, then that becomes the size of the diameter of a molecule of oleic acid, and the value of this thickness comes out to be the order of 10 to the power 9 meter as well. Now we go for the question that has been the 5th question of the session, that has been as follows. The question is, if the size of a nucleus in the range of 10 to the power 15 to 10 to the power 14 meter is scaled up to the tip of the sharp pen, what roughly is the size of an atom, and assume tip of the pen to be the range of 10 to the power 6 meter to 10 to the power minus 4 meter here. So we go for the question here, and that is, if the size of a nucleus that is in the range of 10 to the power to 10 to the power minus 14 meter is scaled up to the of a sharp pen. What roughly is the size what roughly is the size of an atom? Assume of the pin that to be in the range 10 to the power minus 5 meter to 10 to the power minus 4 meter here. Okay, so we go for the same. So size of the nucleus in the range 10 to the power minus 15 to 10 to the power minus 14 meter, that is the tip of the sharp, that has been taken to the range 10 to the power minus 6 to 10 to the power minus 4. Thus be the scaling of the factor of 10 to the power 10, and atom roughly is to be size 10 to the power minus 10. That is being scaled to up to size of 1 meter, and thus the nucleus in an atom is as small in the size of the tip of the sharp pin that placed at the center of the sphere in the radius about a meter long. Okay, so that will be the solution. You can just suggest me if if you are able to solve this by your side or not. You can just tell me in the comment section. It will surely be help you out for the detail as well if you require of. Let's go for the next, and that has been about the range of lengths. About the range of lengths here, we talk about it, and that the sizes of an object we come across in the universe that vary over a very wide range. These may vary from the size of the dark order of 10 to the power minus 14 meter of the tiny nucleus of an atom to the size of the order 10 to the power 26 meter, and that of the extent of the observable universe. That gives the range of the lengths and the sizes of some of these objects as well. We also certain spatial length units for the short and the large lengths, and these are as follows. We'll go for the same. One Fermi equals to 1 F, that is being equals to 10 to the power minus 115 meter, and 1 Armstrong that is equals to it is above, no, it is not a degree. This is equal to 10 to the power minus 10 meter, and 1 astronomical unit equals to 1 AU, which is astronomical unit here, and so that is the average distance of the sun from the earth equals to 1.496 into 10 to the power 11 meter. Now 1 light year equals to 1 light year 9.46 into 10 to the power 15 meter, and that is the distance that light travels with velocity of 3 into 10 to the power 8 meters second inverse in our air, which is being equals to 3.08 into 10 to the power 16 meter per sec, and the distance at which the average radius of the earth is orbit that subtend an angle of 1 arc second here. Now we talk about the measurement of a mass, and that we deal with it. So yes, we go for the same. for the measurement of mass here, that the mass is a basic property of matter. It does not depend on the temperature, pressure, or location of an object in a space, but that is the SI unit of the mass is in kilogram. I hope you all know. And the prototypes of the International Standard Kilogram supplies that International Bureau of the Weights and Measurement, which is BIPM, that are available in the many other laboratories of different countries. In India, this is available at National Physical Laboratory, which is NPL, in New Delhi. While dealing with atoms and molecules, the kilogram is an inconvenient unit, and in the case of there has been the important standard units of mass, that is called Unified Atomic Mass Unit, and which has been established for expressing the mass of an atom. So we can go for the same. 1 unified atomic mass unit, which is equals to 1 U, that has been equals to half 1 by 12 of the mass of an atom of carbon 12 that we have, and isotope, which is 12C6, including the mass of electron, and that is of course equals to 1.66 into 10 to the power minus 27 kg here. For the same, if we go, and that is the mass of the commonly available object that can be determined by a common balance, like the one used in the grocery shops, and large masses in the universe like planets, stars, etc., that is based on the Newton's laws of gravitation, that can be measured using the gravitational method. For measurements of small masses of an atom, subatomic particles, that etc., we make use of the masses spectrograph, in which the radius of the trajectory is proportional to the mass of the charged particles among the moving uniform electric and magnetic field here. Now we talk about the table about it. That is of course being an important one. Let's go for the same. We go for the same, and we made a range and order of lengths here. So we just leave it out. Size of object or distance, and this is length in meter, of course. Let's go for the same. The first we have size of a proton. Size of a proton we have is 10 to the power minus 15. Next we have size of atomic nucleus. That is 10 to the power minus 14. Another we have size of hydrogen atom. That is your size of hydrogen atom is 10 to the power minus 10. length of typical virus? Which is 10 to the power minus 8. Then we have your wavelength of light, which is 10 to the power minus 7. Then we have size of red blood corpuscle, size of red blood corpuscles, which we have here 10 to the power 5 minus 5. Then we have your another one is thickness of a paper, and which is we have 10 to the power minus 4. Then we have height of the Mount Everest above sea level, that is 10 to the power 4. The next we have here is radius of the earth, which is your 10 to the power 7. Then another we have your distance of moon from the earth, which is your 10 to the power 8. Another we have distance of the sun from the earth, and which is your 10 to the power 11. Another is distance of Pluto from the sun, to the power 13. Then we have size of our galaxy, which is 10 to the power 21. Next is your distance to Andromeda galaxy, which is 10 to the power 22. Then again we have distance to the boundary of observable, that is we have distance to the boundary of observable universe, 10 to the power 26. This is how it has been, and yeah, we have to discuss many more topic related to it, and we'll discuss one of them, and that is range of masses here. And from the next we talk about that is about the another table as well, which is range of masses. that we have to talk here. In this, that the masses of the object we come across in the universe that vary over a very wide range, and these may vary from tiny mass to order of 10 to the power minus 30 kg of an electron to the huge mass of the about 10 to the power 55 kg of known universe. In the next table, we'll discuss about the range and the order of the typical masses of various objects as well, and where that we'll discuss in the further classes. Range and orders of the masses, and then after that we'll discuss about the measurement of the time as well, accuracy, precisions, and aspirations that we'll discuss here in the 10th class. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share, and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than this, if I'm talking about in physics class 11 part 1, we had completed unit 1, that is physical world, where we had completed what is physics, scope and excitement of physics, physics, technology and the society, fundamental forces in nature, nature of physical laws as well. In chapter 2, we had started with, that is units and measurement. We had completed introduction, the international system of unit, measurement of length, measurement of masses, then measurement of time, accuracy, precisions and instruments and the errors in measurement, significant figures, dimensions of physical quantities, dimension formula and the dimensional equation, dimensional analysis and its application. In unit 3, we'll discuss about the motion in a straight line, which is about introduction, positions, path, length and displacement, average velocity and the average speed, instantaneous velocity and speed, and then accelerations, kinetic equations for the uniformly accelerated motions, relative velocity as well. Then we'll further discuss about it, which is about the unit 3rd, which is motion in a plane, introduction, scalars and vectors, multiplications of the vectors by real number, addition of the subtraction vectors, graphical method, resolutions of vectors, additions, analytical method, motions in a plane with a constant acceleration, a relative velocity in the 2 dimensions, projectile motion, uniform circular motion. In unit 5, we have to discuss about the laws of motion, which is introduction, Aristotle fallacy, the law of inertia, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, conservation of the momentum, equilibrium of a particle, common forces in mechanics, circular motions, solving problems in mechanics as well. In unit 6, we have to cover up the work, energy and power, which is introduction, and the notions of the works in the kinetic energy, the work energy theorem, work, kinetic energy, work done by a variable forces, the work energy theorem for a variable forces, the concept of potential energy, the conservation of mechanical energy, the potential energy of a spring, various forms of energy, the laws of conservations of energy, power and collision. Unit 7 we have to cover up, which has been about the system of particles on rotational motion, introduction, center of mass, motion of the center of mass, linear momentum of the system of the particles, vector product of the two vectors, angular velocity and its relation with the linear velocity, torque and angular momentum, equilibrium of a rigid body, moment of inertia, theorem of the perpendicular and parallax axis, kinematics of the rotational motions about a fixed axis, dynamic of rotational motion about the fixed axis, angular momentum in the case of the rotations about the fixed axis, rolling motion as well. Unit 8 is your gravitation, introduction, Kepler's law, universal law of gravitation, the gravitation constant, acceleration due to the gravity of the earth, acceleration due to the gravity below the above surfaces, gravitation, potential energy, escape speed, earth satellite, energy of orbiting satellite, and geostationary in the polar satellite, weightlessness as well. So yes, here we're going to end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Stay tuned with us. Thank you, thanks for supporting us, and whatever the topic you require of, you can just tell me in the comment section. Will surely be help you out from that as well. Thank you.